We'll now discuss the difference between what we call direct recursion and indirect recursion. We say that a method that calls itself is directly recursive. So if I have some method which we call A and A calls A, then we say that's direct recursion or directly recursive. Now, if a method calls another method and eventually that method, or maybe through several method calls, goes back to the original method, we call that indirectly recursive or indirect recursion. So just to give an example, if we have method A, and let's say that calls method B, and then method B calls method A, so here we have method A eventually getting back to itself, we say that method A is indirectly recursive. Now, with indirect recursion, it could be several layers deep. So for example, it could have method A call method B, and method B calls method C, and method C calls method D, and then method D calls method A. Now, it took a couple method calls to get there, but we eventually got back to calling method A again. So here we would say method A is indirectly recursive. A couple things about indirect recursion. So it does require the same analysis as direct recursion. So we have to be very careful when we're analyzing and designing indirect recursive methods. So the base cases have to be identified. So we still have to know what those base cases are. And we still need to have non-recursive solutions for those base cases, even if it is several method calls away. Now, the other thing we should mention is because we're calling several methods before we actually see the recursion, tracing through indirect recursion can be a very tedious process. So that's why I said that we have to be very careful whenever we're designing indirect recursive methods. So what we're going to be doing in this course, just to make things simple, we're only going to look at problems that involve direct recursion. We're not going to worry about going over things that involve indirect recursion. We'll now discuss one more issue with recursion, which is what we call infinite recursion. So we see that we have a sequence of recursive calls, and eventually that sequence of calls is going to get to a call that makes no further recursive calls. What we're saying here is that the sequence of recursive calls eventually gets to a base case. We mentioned that before as one of our observations, where if we have a chain of recursive calls, we eventually get to a base case. But what if that doesn't happen? What if every recursive call results in another recursive call? If that happens, then we say that the recursive method or the recursive algorithm is said to have infinite recursion. So here we're just saying that we just have recursive methods keep calling itself forever and ever and ever and ever, and we never get back to a base case. So that's what we mean by infinite recursion. Now, in theory, infinite recursion will just execute forever. It'll just keep calling forever and ever and ever and ever and ever. However, if you remember, every single time we make a call to any method, whether it's recursive or non-recursive, it's going to require the system to allocate memory for all the local variables and the parameters. And then the system will also save that information so that after we complete a call, we can have control be sent back to the original caller. So remember when we talked about that method call stack? So we call a method, so that means we save all the information of the previous call, put that onto the stack, and then execute the method call. So the issue here is we're always allocating memory to save information about a method call. And because our computer memory is finite, if we execute an infinite recursive method, well, we're going to keep calling methods forever. So what's going to happen here is we're going to keep allocating more memory, and we never finish any of the method calls. So since we have a finite amount of memory, we're eventually going to run out of memory. We're just going to keep calling methods and keep allocating memory until there's no more room in our method call stack. And this is going to result in some form of abnormal termination of the program, whether it's an exception or whether the program just crashes or whether the computer bursts into flames. Okay, that last part probably isn't going to happen, but something bad's going to happen if you have infinite recursion. So the whole point here is whenever you're designing recursive methods and recursive algorithms, you do want to make sure that you have some base case, so that way you do not have any infinite recursion in your program.